energetics, more and multiple choice questions. A lot of these are, actually I think all of them are just repeats from what I've previously done, but it's fine. Just reinforcing them. So B and C are absolutely incorrect because ions, standard enthalpy of formation, we're not trying to get that. And then between A and D, well, you just look at the standard states because everything else is the same. Half F2, half F2, Li, Li, LiF, LiF. So you have to look at the states. So in this case, is in gaseous state. That's not true. It should be in solid. Therefore, the answer is D. Question 2. Same thing. Standard enthalpy change equal to standard enthalpy of formation of barium chloride. Can cross out B, and we can cross out D because they're both ions. So left with A and C. Just everything else is the same. So we need to look at the standard states. That's gaseous. That's solid. The answer is C. Ba needs to be in a solid state. Question 3. Cross out the ions. Ag plus, that, cross those two out. Left with A and B. Look at the standard states. That's gaseous. That's solid. Therefore, the answer is B. Yeah, B. Because Ag is silver, and silver is definitely not gaseous. Just one thing before I carry on, obviously. There are one more kind of type of question they can ask you for this small subtopic and standard enthalpy information multiple choice questions. Is when they've got like let me just show you an example right now. Ag solid. Let's say this was A, this is B. So you've crossed out C and D, and what they do now is, I think I've seen this in the 2023 AS level paper 1. But I'm gonna be going through all the multiple choice questions from the past papers again anyway, so I'll probably go through this again. Yeah, gaseous, AgI solid. So in this case, what they do is they'll give you the correct standard states for each of them, but then they'll put you in a bit of a puzzle. Like, you've got a half I2, a half times that will give you 1 I, and you've also got 1 I here. So which one is it? Is it A or B? But then you have to realize standard elements. And iodine exists as I2, not as I. No, it exists as I2, and therefore it is a half I2. Just another trick. It's not B then. When the time comes, I'll be going through that anyway. What is the amount of heat energy absorbed by the water? Well, heat energy absorbed, Q equals mc delta T, where m is the mass of water. So it's just going to be m. Obviously, that's the units for it. That's the units. We're not going to include the units. mc, specific heat capacity, C delta T, Y, mcy. And obviously, I feel like some students would pick B because 2 plus 273, yes, we need to convert it to Kelvin, but remember, for temperature rise, we don't convert it to Kelvin. Don't convert to Kelvin. Question 6. This one I got it wrong the first time. I did this on this channel, which was today, from another lesson. The heat release when 1 gram of ethanol, mR of that, undergoes complete combustion. What is the heat released by each molecule in joules when ethanol undergoes complete combustion? So first thing you need to do is, what I did was I jumped straight. I was like, Q equals mc delta T, moles of mass over mR, delta H is Q divided by moles, and it's got to be one of those. And even if I don't understand the question properly, I can just get it. But in this case, you can't, because it's very specific. It says, what is the heat released by each molecule in joules? So what we have to do first is realize molecule. How do you find number of molecules? Number of molecules. What we need to do, that's equal to the moles times by Avogadro's constant. That's why it gives it us. Think, why would it give us Avogadro's constant if we're not going to use it? We are going to use it. So it's going to be the moles of ethanol. How do you find that? the mass of MR, 1 divided by 46.0. I could see another step to make it more complicated. They put it in milligrams and you need to convert it into grams, but that's just how well you know units. 1 divided by 46 times by 6.022 times by 10 to the power 23. That will give me the moles as 1.31 times by 10 to the power 22. Now that is the number of molecules. I want to find the heat released by each molecule. So how would I do that? What I need to do, what is the heat released by all of the molecules? It's 29,800 joules. So all I have to do is total heat energy released divided by total number of molecules. And that will give me the heat released by each molecule. And that gives me 2.28 times by 10 to the power minus 18. And obviously need to convert kilojoules to joules, just times by 1000. And then question 8. Definitely a lot different. It's about enthalpy change. Some enthalpy change data are shown. What is the enthalpy change in kilojoule per mole to the power minus 1 for the following reaction? What you have to do for this one is you have to manipulate the equation. So I label this equation 1, equation 2, and I want to get to this equation 3. So how would I do that? Well, if I times the second equation by 2, I'll get 4 H's, which I want on the right hand side. And I also flip the first equation, reverse it. That's perfect. So that's all I need to do. So flip the first equation, so I get CH4 gaseous forming C solid plus 2H2 gas. And what will happen to the delta H? Well, because we flipped it, it's going to be negative 75, and therefore it's going to be plus 75 kilojoules per mole to the power minus 1. For the second equation, I want to times it by 2, so I get 2H2 gaseous arrow 4H gaseous. And now what will happen is that 2H2 gaseous, that 2H2 gaseous will cancel out, and therefore I'll be left with CH4 gaseous, C solid, just adding them together, plus 4H gaseous. And that's exactly what I want for equation 3. So, it's a bit of a manipulation, times that equation, reverse the first equation, and then once I've got that, now how do I find out the enthalpy change of that? Well, all I have to do for this is the enthalpy change of CH4 to form C solid plus 2H2, 75, plus the enthalpy change for because that's the enthalpy change for that. The enthalpy change for this is 436 times by 2, and all I'm doing to these two equations is I'm adding them up. So surely that's all I do. All I do is add these two equations up, therefore I'm adding the delta H's. So add 436 times by 2. 75 plus 436 times by 2, 947 positive. This is a tricky one. Definitely very tricky. You have to reverse that, reverse the delta H, get positive. Times that by 2, add them together, realize those two cancel out, you get this, and then what do? Do delta H of that plus delta H of that, and you should get plus 947, and that's the end of the enthalpy change multiple choice questions.